Hello all and welcome to this session of object-oriented programming. In this session, we are going to understand basic object-oriented programming concepts which include object, class, encapsulation, abstraction, inheritance, and polymorphism. Let's first start with understanding of object-oriented programming. Let's have a look at what the definition of object-oriented programming has to say. So, object-oriented programming is a computer programming model that helps to organize software design around data or objects rather than functions and logic. So, what we have in object-oriented programming is object is something which is used for data transfer, calling functions, which can be termed as a communication within your application. So the focus is more on data and data security, data hiding, rather than functions like we write applications in C programming language. Now, how we are going to have object defined? So an object can be defined as a data field which has got unique attributes which are termed as characters as well, which will hold the data for us, and the behavior. Behavior is nothing but the operations which we can perform for that particular object. What are the benefits of object-oriented programming when we use this paradigm for developing our application? Namely, modularity, reusability, scalability, and effective troubleshooting. Modularity means your program will be divided into separate modules and each module is responsible for specific functionality. So related business logic can be kept together within a module. And such multiple modules we can create, and every module will be independent of each other. Reusability. Whatever modules I am creating, we have a very specific or very easy way to reuse the existing functionality so that there is no rewriting of the code and there is no redundancy of the code. Next benefit is scalability. Whenever you need to scale up your application, means what? I want to add new functionality to my existing application. So what I'm going to do, simple thing, as I have already mentioned, the application will be divided into small modules. So when I want to add any new functionality, I will create a new module with the expected functionality and add it in my existing application. So in this way, object-oriented programming applications can be scaled up easily. Next benefit, effective troubleshooting. Obviously, what we are going to have is we are going to have an application which is having multiple modules utilized into that. That is the integration of multiple modules. Now, whenever I'm executing my application and if I'm not getting expected output, how I will be able to track that exactly which part of application is not executing as expected. Now, as I have developed my application using modularity, I know that which part of application is exactly responsible for what functionality. So, when a specific functionality is not providing expected output, I can directly check in the module that what is wrong with the logic. This way, when we have segregated business logic in a proper modularized fashion, error tracking also becomes very easy. So these are the benefits of object-oriented programming. Now we are going to discuss about various concepts like object, class, and other object-oriented programming concepts. So first, let's start with an object. So what is an object? So let me tell you one thing. In Java, object is a runtime entity. Objects are created at runtime and memory will be allocated for that object whenever the object is created. One more definition of object is it is instance of a class. Okay. Now, what is class? Yes, we are going to discuss in a while, but what object is? Object is instance of a class. What an object is going to have? Object is going to have state and objects are going to have behavior. What is a state? As I have already mentioned, the properties or the characteristics of that particular object represent the state, right? Let's have a look at this particular example. So we can see multiple objects around us in real life, like a car is an object, a book is an object, person is an object. So I have considered one example as a dog. So when I look at the dog, every dog has same features. However, those feature values are different. Feature in the sense what? Every dog will have specific breed. Every dog will have specific size. Every dog will have age. Every dog will have color. So these are the common properties. Now values for these properties for every dog will be different, right? So breed, size, age, color are the properties of an object, and whatever values are stored for that particular dog represent the state of that particular dog object. Okay? Now, dog can perform various operations, certain functionalities there, like wagging the tail, barking, eating, sleeping, sitting, running, etc. So these are various behaviors or operations or functions which are being performed by that particular object. Whenever we are going to use object-oriented programming, obviously we are going to create objects. Objects are going to have states and objects are going to have behaviors. Now, behaviors are responsible for changing the state of an object. This is a very important thing. Behavior is responsible for changing the state of an object. Let's say, for example, right now, dog is sitting at one place. So I have located what is that particular place. Say in garden, dog is sitting in the garden. So location of that dog is garden. Now there is a functionality for a dog which is run. So dog has performed that operation and moved from that location to some other location. So now the dog is sitting on a sofa, say for example, right? So what is changed? The location of the dog is changed. The location, say, was part of the state of the object. So run operation is responsible for changing the state of this particular object, right? This is how state and behavior are related to each other. Next, we will see what is a class. A class is blueprint from which objects are created. Now, when I say that I want various dogs to be represented, right? There will be state, attributes, characteristics for a dog. Also, there will be some behaviors or functionalities for a dog. So where is the design, right? So say for example, whenever a builder decides to build a building, right? So does that builder directly start building that particular building, or first the design is there and then it is finalized and then actual work starts, right? This is what is done. First the design is ready, then the actual work is being started. So here also, when I say that there will be this dog object will have these properties, dog object will have these behaviors, I need to have all these things represented somewhere. So to represent what will be the properties and behavior of an object, we have a class defined, right? So whenever we are using objects and classes, we start with first creating a design or a blueprint, that is nothing but a class, and then we are going to create objects for that particular class. Now, how many objects can be created for a particular class? Any number of objects can be created. The class is going to specify that what all properties and behaviors will be there for that kind of object. This is what a class is going to do. Next, now we are going to discuss about the object-oriented programming concepts, four concepts: encapsulation, abstraction, inheritance, and polymorphism. So let's get started with encapsulation. So what is encapsulation? A mechanism of wrapping data and code acting on the data together as a single unit. In short, what we are going to do in encapsulation is we are going to capsulate, we are going to put together certain things. So putting things together is nothing but encapsulation. Now in any application, what things I'm going to put together? Obviously, it will be the variables, the data, and the business logic which will perform certain operations on that particular data. In short, in other words, creation of classes is nothing but encapsulation. So simple thing, what we are going to do in encapsulation is we are going to create classes. We are going to specify what all properties will be there, what all variables will be there in a class, and we are going to define the functions which will perform certain operations on that particular data. Is that simple. Next is what is provided, or what is the outcome of encapsulation is data hiding. Data security is what is focused by object-oriented programming languages. So that data hiding is effectively implemented through encapsulation. So what we are going to do, how we are going to achieve encapsulation, and through that we are going to achieve data hiding, is we are going to create variables in a class and we are going to make them as private. Private is an access modifier, and once we declare these data members as private, they will not be accessible to outside world. So we are going to provide certain methods which are termed as setter and getter methods to perform operations on this particular data. Obviously, whenever we will start implementing classes, we are going to discuss on this particular point through practical example. Next is abstraction. What is abstraction? A process of hiding the implementation details from the user, and only the functionality will be provided to the user. Let's take an example of a car. Now, car has got various parts. Engine is there, steering system is there, gear system is there, then brake system is there, and number of things, right? Now everything is put together and represented as one entity. That is nothing but a car. So what is implemented over here? You guessed it right. It is encapsulation. Now, so I have a car. I need to drive car. So what I need to do when I need to drive car? Do I need to know how the parts in that particular car do work, or I just need to know that okay, I want to drive a car, what are steps which I need to follow so that I can drive a car. So 1 2 3 4: ignition key, gear change, accelerator, clutch, brake, indicator, and go on, right? So whenever I need to perform certain operations using that car, I need to know only what is required from my side, from my front. I don't need to know that how the engine works inside a car or how accelerator system works inside the car. That is not required. I'm not a mechanic, right? So that is nothing but abstraction, right? So the user will have only that information on what object does instead of how it does. So I know that whenever I'm using that ignition key to start the car, engine will start its working. So I know what is happening, but I don't know how engine exactly works. And it is not required. Now we are engineers, so we can imagine हमने पढ़ा है and all that. But a layman may not know all these things, right? Now, how abstraction is achieved in Java? That is achieved using abstract classes and interface. So obviously this is again we are going to discuss in detail when we are discussing about these concepts in Java. Next is inheritance. Now this is very important feature which allows us to reusability to be implemented in our application. Now, reusability is what we have also seen in the features of object-oriented programming. What are the benefits of using object-oriented programming? Now, reusability can be implemented in two ways. One way is has a relationship. Another way is a relationship. Has a relationship means one entity is part of another entity. Like I have two things, person and address. So person has an address. So whatever functionality is there to define an address, that is available inside person implementation, right? So that is has a relationship. Another relationship is a relationship, or it is also termed as kind of relationship. When one entity is kind of another entity, it is called as is a relationship. Like say car is a vehicle, or dog is an animal, cat is an animal. So what we can have is instead of rewriting the functionality again and again in various classes, we are going to reuse what is the existing functionality. Let's take an example. So say for example, I have a calculator which performs basic operations like addition, subtraction, multiplication, division, modulus, and equal, right? Now I need to design a new application, or I need to develop a new application which is scientific calculator. So obviously scientific calculator is going to have some added features, some more what I can say operations. But when I say that there should be some more or added features, what about the basic functionality? basic functionality has to be there, plus new functionality needs to be added. So instead of rewriting the code, I can give it a thought that whether I can implement this through inheritance. So what is the criteria to decide whether I can have inheritance is a simple check that I have two things. One is calculator, another is scientific calculator. So whether scientific calculator is a calculator. If the answer is yes, I can implement reusability through inheritance, right? So what examples we discussed earlier? I said car is a vehicle. So when can I implement this relationship? Is car a vehicle? Is dog a vehicle? No. So there will not be is a relationship. Now there are certain terms which are used. So the class which inherits the properties of other class is known as subclass or derived class or child class, which is going to reuse the functionality and add new features to it. So in our example, scientific calculator will be the subclass or derived class or child class. Now subclass, derived class and child class, these are three terms used for same entity. And the class whose properties are being inherited is known as superclass, base class or parent. Obviously, we are going to discuss in detail about inheritance once again through implementation and how we are going to implement inheritance in Java. Next concept in object-oriented programming is polymorphism. So what is the definition? When one entity is available in multiple forms at the same time, it is termed as polymorphism. So one object has an ability to take many forms. What is example of polymorphism? The best example is a human being. We play different roles at the same time. So one person is playing multiple roles. One person is available in multiple forms, right? So that is a real life example of polymorphism. Now, whenever we are talking about this, the program will determine that which form of that particular multiple forms is necessary for a specific execution of that object, and in this way we will not have any duplicacy in the code. Now polymorphism is of two types: compile time polymorphism and runtime polymorphism, which will be discussed in forthcoming sessions, obviously. But polymorphism is the way to represent one entity in multiple forms. Obviously, one form will be used at once, and the application needs to decide which form of that particular object is exactly required at a particular point. So that is nothing but polymorphism. So what we have understood in this particular session, various concepts as class, object, encapsulation, abstraction, inheritance, and polymorphism. Thank you.